that streaming? Yeah. Right. Hello. Is that streaming? Yeah. Oh, we're online. So I want to get chat messages first. And there you go. Can't do something like that, I guess. Alright, that's fine. Well, hello friends. Today I'm gonna be working on simple math parser in OCaml in here, as you might see. Maybe we could just like a little bit and get a bigger screen, and that's fine. I installed on WSL. I actually tried with the native Windows, but that didn't work. So, let's open a music. What was that? Lo-fi. Alright. Let's open the. Yeah. Yeah, that's fine. I think so. Well. So, what do we have in here? Firstly, let's delete or not delete this operator type. So let's open a terminal or a terminal in here. Open a sandbox terminal inside the OCaml and dune build and dune execute binary.exe. So it parses a token in here. Main.ml. We're trying to parse a string something like this. We are also turning stringing the chars and charless to string and print an line over here. So it works something like this. So what are we gonna add is that we need to add the operators, and just like the tokens, the operator actually has some functions to add. So token operator.ml. We're adding this file, and we are going there. Later, let's add operator first. So it has some error no config file because we gotta do dune build. So we're just going in here and there you go. No config. Alright, let's do dune build again. It's probably just went out. Yeah, that works. So what are we gonna do is I'm just gonna generate these name of token, the helper functions for that. So let's go in here and let's open ChatGPT. That's my lab.ml file, and here and that's operator.ml. So let's add our helper and helper testing functions, just like and tokens, and add operators as token to token type. So we extend it, and we're gonna open the type op of operator. So I'm just going there. Is there anybody watching my video? I think so. It's not. That's great. Never mind. So open operator, and we are setting op as of operator. And we are also adding this, the name of the token, and we're setting as operator. Constructor operator expect one argument, but it applied 0. So we have an appliance. Oh, right. Operator, maybe something like that. How are we going to access? All right. Oh, I see. Yeah. So, we're just setting the name of the operator. So let's go in here again. Extend the token system. Name of operator, char of, and operator of char. We're copying that stuff and pasting it. Extend the token helpers. So name of token. Oh yeah, name of operator and operator. Yeah, it just extends by itself. So let's copy all of this stuff and let's go into here. I think it's going to work. Unbound value of name of operator. So yeah, I have that name of operator, but we can see it in here. Unbound value. Why? Let's do build again. We don't have that. Because it's not an OP. But I think so. We're just gonna say an OP. Right, now it works. That's great. So we all set it down and printing the token list is that name of token and char token. So it's not really changing, I think so, a lot. View and test. It works fine. Let's go to test file and actually write some test. Let's write test functions for operators. Alright. So I think it's enough. Test operators units. Open utils and used open as utils. Delete new test. It's not working. So what it takes nothing, and it's not working. So maybe if we could do something like this and here, actually, maybe just pipe it. Yeah, it works. We're piping nothing into that. So operator nav, addition, char, token. So I guess we gotta assert that. Do we have asserts? Maybe we could test them with asserts. Alright. We have a large test file. Pipe it into test operators. Sorry, we're not calling this. And test operators, we have test operator section. Let's do and test. You don't need utils. Actually, in here, let's also write test or utils as well. So nobody just came in here. I hope. Yeah, my stream's kind of a little bit slow, but I don't really care because nobody's watching. And we also have to test utils. So we could just go in there and add here and let's test utils and use the value because run operator test and test utils. Alright, how about this? Let's test all equals pass the test operators and test units and yeah, for function. Less test all equals just equals a function. I think so. How a function works, a pattern that takes nothing and test operators and test utils. I think so. It's gonna be one. It's not unusual. Yeah. We actually have to run it. So how about this? Equals fun. No, it's not going to work. Let's nothing equals to test utils, but no. This expression should be not a function. Alright, I see. Let test all equals a anonymous function, and we're running this by this, and it works. All operator test passed, all units test has passed. So and we're just going there with a string all tests passed into the string. Alright, what do we have in here? Well, it's not working. This expression is type unit. This is not a function. It cannot be applied. So we're just gonna take a smaller function. Which takes nothing. And yeah, it works. That's great. So maybe we could just do something like that. Test utils and a function all test passed. That's gonna work again. I think I kind of like this language, but we could do just in one line. I think so. Because why not? So we added a test and some operators first. So let's add the operators. I think that's enough for that. And what kind of operators do we have anymore? It's not. I think so. Let's go into there again. Nobody's watching us. That's great. So we actually added something. Let's go into the ML and how about this? 1 plus 2. What do we have? What are we gonna have? Doing build and do an execute binary main.exe. Fatal error because it's an unknown character. Because we don't have, we have the token and name addition and the value, but we don't have a token type. So what are we gonna do is that token name addition. So what are we gonna do is that let's go into the print token list again and let print token. It takes us a token, and what is we have token into can we turn char of token name of token is an addition, but we don't have type of token. So we should, I guess, add the type of the token first. How we could do it? Well, I don't know. I want to add print token, name of token. T name of token and print string. And count line. Do it. Alright. Print string. The name of token. We don't actually need that. just going to push that into. Oh right, yeah. I see. You know what? I'm just gonna do some stuff and paste into the chat GPT. So add operator helpers. Is there anybody watching us? No, that's great. So I guess we have to figure out types of tokens now. Because we can see now. So let's add token types. Type of token. Yeah, we have some token types as a literal and identifier, phrase, operator, print and token list, the name, the char of token, and a token type. It's gonna be something like this, a type of token with. Yeah, I see it. Token type operator. Well, that's great. So we gotta add a token type. We have phrase. We don't really have. We have separator. And just expression. We need identifiers. So type separate. What's that spell? Separator. Separator. Spell is separate. Should be separator. So we have our brace of. Can we do something like this? I don't know. Oh. Wildcard is not allowed. Why can this and type declaration? Well, that's bad. OP of operator, sep of separator. Let's paste it. Let's see what do we gonna have. Literally nobody's just watching it. That's great. Well, type separator. Number, alright, and token categories or of separator. Can't be just where with mapping types just like string enums. Yeah, can't do it. Char of separator. That's great. Yeah, that's great. So we have the token. Alright. have. What do you mean by that? Oh, right, yeah, there we go. Yeah, like the name of operator is, what the fuck by function? Match s equals match s with equals s equals match s with bad name of operator. No. Look back again. Kind of. Alright, char of token. Yeah, we also have this one. Operator of char. Yeah, and here, instead of writing characters, could map match every single of list. So this we need a helper function for turning all times into char lists. Separator chars. Operator chart. Char the token mapping. Token mapping is char separator in S. What is S? So we have combined mapping char to token mapping. All tokens is chars. Alright, I don't know what's that. Centralized mapping. So we have. How could we turn this mappings to dynamic instead? Somebody watching us? No. Oh, there's somebody watching us. Hello? Hello. So we need to add some all operators, char of operator, char of separators. No, I guess we can't do that. Separator chars, char of separator and all separators. That's just great. The all separators are a list. How could we create all separators from this type? Can't we just map and create us a list for that, and after that make a list. Have to list them manually. That's great. Fuck. Separator chars. So nav fun takes an S. Char. That's but I don't want to do that. I don't want to do something like this. Instead of, so we have the all separators. So we're just gonna push something like this. Let's separator first equals list that map, and we are actually pushing our function fun as and we're turning that as char of separator, pushing that into the all separators. Could do something like that, I think so. But firstly, I think should push the all separators. So all separators into this. Just delete this one, maybe. Alright, so we have a couple more here. Separator char. This is not a function. So what map does is that A list, B list. So the first variable is a function, and after that it takes a list. So we are first binding this function, and could do something like that, and it's gonna be work. Delete this, and do no, can do. Alright. We have an anonymous function that takes a separator, combines them with char of separator, and you're mapping this one. And let's do the same thing with names. So names equals the all separators, and it goes that name of separator. Just hold this thing down. So what do we have in here? Let's do build. And so we still have some problems. Right. So we got all the names. So we need separator chars in here. So match with OP and just delete them. Oh, sorry. If we have separator, that just map. So list that map. So let's take our function in here. We are gonna be map with this. So chars of separator. No, not this one. Separator chars. Separator chars. And we are pushing them into a function that takes the char and what are we gonna do with that char? We're just gonna actually match. So match cvif. Could do something like that, I think so. Match cvif the separator chars. What are we gonna alright, or where here, yeah. What could do in here? So match charvif. We're gonna match all the chars with all the characters. So in here, how are we going to dynamically match them? So I guess we need a list that combines of all chars for all tokens. Exactly, yeah. Alright, the separator, token, char separator, all separators, separator chars, all the operators. Yeah, we gotta do the same into the operators again. So let's go in here and let's take this one. Let's go in here. Let all operators. Is this somebody watching us? No. Alright. I see somebody actually liked my video. That's great. All operators equals a list of addition, subtraction, multiplication, and division. That didn't work for some reason. Yeah, now it's working. So we have all the operators, and let's go in here and let operators chars, operator chars, and all operators into a function that is char of operator. Alright, you know what? We could do another layer. Could do better than that. I'll show you. First I'll do it. Char of separator. Char of operator. Name of operator. All operators and operator. So you might see it's actually kind of similar with each other. So we already have a function that turns the name of operator. So what we could do is that let generic fun generic map fun could actually just maybe just char of operator. Right, is it going to work? I don't know. Is it going to work? I don't know. But I want to try it. So let's go in here. We're just gonna fail it. I think it works. Token. No, we don't have unknown token here. Alright, so yeah. We don't want that. So I think it's going to be work because it just lists that map and it takes a char. Yeah, we're actually doing the same thing in here. So I think instead of a generic function, we could just name of operator. We could just set name of operator in here. could we do is that have yeah, I think that's gonna work because it's the same thing. Let's ask. Does same with delete function first function or second version. No, we could just map, just pipe the function into the map. Why not? We could do it. I think we could do it. Why not? I'll never switch me. It's gonna work. So let's go back in the token section and have some mapping with the token of char. So we're gonna match C with what? And here we have extend the token system, so module, string into char, add operator helpers. So what do we have in here? All separators, all operators combined, char to token mapping equals the char to token mapping is separator chars and operator chars. Char to token mapping. Let's go and take this, the combined mapping to the table, and look at function is a dynamic matching the token of char as a go btc and char to token mapping with sum t equals t non-fail with unknown character. So if there's something listed optional, so you're just gonna map this where associate optional. So we're searching that. We have a lookup function for that instead of just we're gonna use the built-in function, I guess. Char to token mapping. What? The value of is a list, but expression was accepted. Type the char. What the fuck is that? I don't know what that means. Optional. Alright. So that map, separator chars, combine them. Char to token mapping is a list. Let's try with that. What happened? The expression is type list, but expression was accepted. So what are these? Char list. So I guess we gotta try first fun. The char list again. There's nothing going to be changed because it's the same. So this char is not compatible with type char times token. What does that mean? Right, so we definitely have some problems in here. So we have string list and we have char list, separator chars and operator chars. So char list. Oh, what it takes. It's combining actually. We're going to try char to token mapping. So it's not take what are we char to token mapping. So instead of that, let's let all chars of tokens equals chars separate chars and combine them with appends with the operator chars. So instead we could do something like that, all chars of tokens, and it's not going to work again. Why? All chars has list, but expression was expected to be char and a type. So we have char and a type. What it takes, A, first, returns the value associated with the key, C, and a pair. So what it takes is not something like that, I think so. Alright, maybe it's taking a tuple. Exactly, yeah. Such as list of characters. So separate characters is actually just a function. Map them to char equals to tokens. Combined mapping operator chars, separator chars. We're gonna map this into something like that, I think so. So let's try this again. It's probably going to work. So let's try it. Lookup function. Let's try the lookup function. It's going to be work. Yeah. So let's do execute main.exe. We have name addition and value plus. So it actually works, I think so. Because we gotta map them into the char token pairs. Fun operator is char operator and the operator by itself. So we could just do some listings or just mappings, type mappings. Could just go there and do something like this, I think so. So we have some mappings in here. Char of token, name of token, separator chars. So let's go to there. Just use instead of this. It's not working because separator chars list of, right, we can do something like that. List of separator names. So what are we gonna do after that? Is actually, you know, it actually uses the char of separator as with all separators. so we're just gonna be use this as no. So we have a function that map, combine them with the token. So let's open token about model token. Why? Why not? Token is usually can take open utils can take the well it's kind of weird actually. That's my current implementation. List separator chars, char separator, all separators, list of operator chars, list of map, explanation, and also write list of separator names, all separators into list of map, name of separator. But also we need to map this like this. So what are we gonna do now? My brain just got fucked up. I need a dynamic separator info, and operator info is gonna be char, token, and string list. Fuck. Yeah. We have lookup functions. Some. Oh my god. Well. Char of separator, the name of separator, and all separators. Oh my god. Oh my god. Map command list. Char, token, and name. Yeah, we actually have an info list. And we have a lookup functions. The token of char, name of token, and we have lookup functions now. Token of char. Here. Print token list. So is it going to be work? Yes. Name of token. Something like this. And char of token is something. Let's add the lookup functions. So we can just delete this stuff. Print token list and tokenized string. So it's going to be the same thing, the name addition and value as a plus. Well, my brain just got washed. I gotta take a quick break. There's 50 minutes, so I gotta be back. So what we did, let's go and see. Firstly, we added test functions. So feed tests add generic test functions. Commit. Let's go to main. Nothing got changed. We have operators and separators. We have some tokens here. We have utils. So feed add separator token type separates tokens into different classes. Feed lexer tokenizer. Right. Yeah, just save it. It's gonna work again, and it's probably going to be work. Let's see. Feed at modules. Right, so what do we have now? Let's try to work it again, and we have everything. To name, right, brace, addition, and value dim. That's great. We could actually just, let me give an example. So I'm gonna format first by name. So let's go into the token, and we have print token list. So I wanna pre-print them. You might see their columns right now. Really formatted. Jagged. Alright. String.make. Right, let's see what is gonna be. Token name, left brace, right brace, and addition and chore. Yeah, it's better, I think so. But we don't want it. You want piping. The syntax is good. Also add table printing. So add the outline of list. Full table view. The print. Right. Print bottom line. String of token type. No. Print the token list. So let's see. What do we have in here? Invalid format. Right. And value. String of token type. Let's add it. Type of token. We have token types, right? No. Yeah, we have. So let's give this. Use a string convention or hardcore for left char. Let's go in here. Try this. It's not pretty working fine. Let's try this one. Right. It works better, I think so. Maybe this column. Outline has some problems in where print the table header. So we have times s n in the bottom line. But I think it works fine. The token name, char, and type separated. So column name. Alright, the type of it, maybe it's gonna be 9 or 8. How about 4? No. about the column? What's the headers? Print the table header is actually line. Alright. Not the white of the lines are not fit together. Yeah, it's unnecessary, but I like doing this. I really like doing that stuff. I like pretty prints. I like it. Nobody can stop me for doing this. Type, what the fuck? Wait, what is that? Down the tables, print token lists. What the hell this is gonna be take? Well, let's try it again. Example. Alright. So I will go to this guy and ask it. I want pretty print. I want pretty print for my token. Calculate maximum lengths for each column. Total width for the table. It's all gonna be the same, I think so. Well, let's try this. Yeah, we have. Alright. Test 0. Token name and type. Why we are writing 0? I don't know. Go in here and do write tests. Anything else? Need that. Alright. Works fine. I think so. Type. Separator. It works all fine. How about this? Addition. Yeah, that works fine. So, how about this? Let's turn this into a generic function that takes a list of A and print them with polymorphic types. Here's a generic table printer. So we have utils, type a column, print table. Yeah, I think it's going to be work. Extract string make min width. Yeah, let's see. Print token list. Let's go to token. Just delete this. Anything more? I can use that. Unbound record field header. Why? We don't have print table. We should have. Why? It still works for some reason. I don't know. Let's close it and open it again. It works. Let's go here and plus. It works. So feed utils add generic for any type. Oh, type of token, string of token type. Feet, tokenizer, at type, at type name findings of tokens. Yeah, let's sync it. And I'll be back. Just let's take a break. Oh, we didn't actually change it. Yeah. Coding stream free writing. A parser in OCaml. Yeah. Alright. Yeah, we're just gonna change it into something. Let's go into there and OCaml parser, compiler writing, live coding, OCaml live, functional program, tutorial. Alright, let's add all, and we gotta edit. So let's go to fluidity.com because we gotta add a simple OCaml thumbnail first. That's not what I want. Thumbnail. OCaml logo. Yeah. Let's copy image. No, not this one. Copy into there. Guess we can't do it. It's gonna be top of that. We can't. Alright. Coding stream. Are we in 3? No. 4. Go to one channel. Now let's check which streams. Yeah. This is the third one. Coding stream. Free. This one. And let's add some strobe with 2 pixels. Alright. The fuck is that? Nope, not this one. Let's change the color into some decorate. Let's go background. Yeah. So we're fucked up. It's a noise. We have something in here, but it's not going to work. Yeah. Maybe how about an anchor? No. Reflected? No. Or radial? Yeah. This could work. Yeah. How about this? We're just taking this into the OCaml color. Which one is the OCaml color? Let's go color picker. Let's call it picker, and we're just putting. Can do that. Let's save image. And color checker. Gotta be fucking kidding. Under 10. I did it. Use my image. Alright, let's copy it. Extensions. Dark Reader is not working, or I didn't even install Dark Theme. I installed it, but I can't see in here for some reason. I can't. I don't know why. I think it's gonna be work. Yeah. So let's do something like this. And that is working. OCaml coding stream. This is another font. Yeah. Writing parser. OCaml. Yeah. Let's get transfer controls a little bit smaller one. Do a white stroke here. Yeah, why not? Maybe here we go. And do we have any camel Bojack? Camel. Yeah, we have. We have. Yeah, there you go. There you go. What about this? OCaml. That could be work. And OCaml. Let's go to text and delete this. Yeah, that could be work. Export as PNG. And also the PSD. So let's go back into our screen. Changed, so I gotta be back. Yeah. Let's go and add a text in here. Back. Yeah, there we go. Right, I got back. So, what is the next step of it? We're gonna add the expressions. We have to evaluate them, but first we also have to get the AST, the abstractive. What was the meaning of AST? AST in others. Abstract syntax tree. Yeah, we gotta build something like this. So, we're gonna add the expressions.ml. So we have expressions, and let's copy this one. So let's go there and type expression. What kind of expressions do we have? This is a simple, actually that's just a simple math equation, so we don't really need expressions. So don't really need an expression, I think so. The expression is, according to my notes, let's go into our notes and programming and language basics. So what do we have in here? Atomic is cannot be broken down. A value is the result of evaluating expressions, a concrete piece of data that a program can use. An identifier is a name, and the literal is an atomic representation of a value written in code. So we only need to add literal and a compound expression. So all the values are expressions, but not all the expressions are values. So we don't really need to get an expression, but I'll just do it because I gotta use that code and somewhere else. So what is an expression? Is what are they? It's just the literal and atomic representation of value directly written in code. So how we can implement expressions? So let's ask it first. Let's go into ChatGPT. Let's go to the parts. Hello. We could do extend token system. How could we implement expressions, since it's just a simple math parser? The only expressions are, first, what are the expressions? So expressions are just representation of tokens, right? So an expression is just a list of tokens. Excellent questions. Yeah, the expressions are just actually a list of tokens. Number, grouped, binary, operator is an expression. Arithmetic parser, that's enough for handling things like expression and token relationship. Parse expression, the token. Expression is a value and binary of operator. It's an expression. So the token type, something like that. So the expression is number of float, the binary, and grouped. So I'll just say in here, what is a binary expression? Type bin expression is something like that. An expression. First, what is it? What is an expression? Type expression is, yeah, we could just do this. Number of float, an operator. So what is an operator? Let's go into here and open. We could do that because we gotta add expressions. Expression.nl. And could just add open operator. Open operator. Yeah, just do this. Doing build. So we have a syntax error. Type binary. So binary is something like this. Binary expressions are operator. Expression and expression. Well, first, right. So expressions are something like this. Addition, number, free, binary, multiplication is a group of binary. Alright, expression type in your token system. So the expression or value of a float and binary of operator. So we don't really need group. So we have number. Number of float and binary of operator, but two expressions. So I guess that's enough for that. What could we add in here is something like this. Expression of. So let's open expression. We have this, but I think we could just do expression. Close it and open back again. It's not working. Why? Where's that? Gotta be fucking kidding with me. Let's open the mail. Alright. So what is X? Alright. Expression. Of expression. What? A band model expression. But we already have. So let's close it all. Try to do this. Let's go token and expand it. Type of token is expression. Bound constructor. Expr. Type of token. Expr. Yeah. It works. And bound model. Let's open it back again. Gotta be fucking kidding. Wait, why we couldn't find it? There is. Never mind, it just works. It works. So let's do it. So when we try to add, for example, 1 plus 2, what we are going to add? The unknown character. Where is the unknown character? Is in here. The token of char. So sum type, put in it, the old token info. So we also need to generate a token info. So let expression info. So we need that. But how? We need to get some kind of list that has all the possible values. So how we could do it is let's plus just actually I guess 2 9 no, let's create a list. Should create a map. We should create a map for all possible expressions which number 0 expressions which all numeric numbers. So how are we gonna map this first? Let's see it. Tokens versus expressions for numbers. For parsing, they're just like dot. So the numeric of float. Why? Adding numeric expressions in token level. Tokenized chars. Well, we have a number of floats. So number of float. So let's delete expression first. The token type is just a number, right? So let number info. We don't have that. All token info. Look at generate. Number info, all numeric numbers. How we could do it? Check number char. Yeah, this is number. It's bigger than that. And while number char. Yeah, there we go. This number char. Let's go to utils. This number char. Number of string. Try num. Float of string. Real number. So let's add these math utils. Math utils. We don't have num cause the number of string. Gotta add open token here. We don't have numbers. Try num float of string, number of string. So I'm gonna write in utils. Let's do generic map utils. Token name. Type. Number, the separator info, the number info. What is the number info? Is that as a char token string equals a list of number. It's dynamic. If you really want, you can make a dummy entry to show what type looks like, but it won't enumerates, and then all token info. So define token by metadata. Well, how about this? So well, got a map or filter. So instead of info, cause the old separator info, it's a function that checks it's a function or not. So how we could do it? I want to add numbers into the mapping, all tokens, but since numbers are infinite, how we could do it? By functions, or we have to change the lookup function. Right, instead of that, the token of char, sum t find opt, the all token info. Modify lookup table handle numbers. Tokenize helper, not single chars. This now needs to work on streaks, not single chars. Tokenize helper. So the chars are char list, the accumulation is the token list. The C rest when accumulate digits into the form of a number. C rest, the tokenized string. Or keep the separate handling, the type of token to num, and update name of token into that. This digits. It's better because fundamental different from parser from sequences of characters not looked up a fixed mapping. Yes, it is actually. So the type of token is a number. So we gotta add it. We gotta add the number in here. The type of number is a type of number. Type of token. No, not here. Type of token. There we go. We have this. Now is a number. And the name of token here. Let's go name of token. String number equals number. Print token list. Where is that? The name of token. So we have name of token, and if it's num, is a printf or not. Now let's update this one. Match token with num. If it's num, the printf is printf with 2 or char of token. Token. So we also going to set this differently for numbers, the placeholder or handle differently. So the char of token, there's no char of token number. So handle differently. Is digit and the tokenized helper. Let's go with the first strategy because tokenized chars cannot work with literals like numbers or strings. The all token info, look up functions, name of token, print token list and tokenized string. Tokenizer that handles multi-character numbers. The tokenized string says string and token list. Let chars string to chars. S in let recursive tokenizer helper remaining char list and accumulator as a token list. Handle white space, skip it. Handle numbers, C rest when digit is X. Take number, count chars remaining. Match remaining with D equals rest. Oh fuck, what is that? Reverse the remaining, what the fuck is that? Handle operators and separators. So we need tokenized string. So what do we have in here first? Our current implementation is just tokenized string, and we are turning string into chars. And listed map token of char. But it's not working. Current implementation is that token list. We are trying to tokenize firstly, but we have to tokenize string. It calls a tokenize helper. So we gotta handle white space, skip it, and handle numbers remaining. Let number float of string num str float of string remaining. So what is that function does? So what's our tokenize helper does? What are these guys doing? Firstly, I will ask it. Somebody's pushing it. It's a core tokenizer that handles both literals and single character tokens. So handle literal. So we need a tokenized literals first. So firstly, the literal handling and the lookup handling. So we could parse them to tokenize. Let tokenize. It takes a sequence of string and returns a token list equals. Yeah, it does this, and we need remaining also. We could do it. A string, the remaining, the accumulation. Alright, so remaining is a string, it's a char list. And accumulation is a list of token. List. And it returns us a list. But we could just say this into a string. Tokenize is actually just a tokenize str tokenize code. This string accumulation or yeah. So I'm just thinking about that the tokenized parts that it's gonna be turned into the two parts, right? So the first one is let tokenize char, and the tokenize, it takes a char, and it returns us a token list. So it's gonna be something like this. So it's gonna be return nothing, so just to return an empty list for now. And also the let tokenize literal, which takes us a string. So the str is a string, and it's gonna be return us a token list, right? Because this one. And let's we have the tokenized code. What is gonna be have? So we have the remaining code. Remaining tokenized loop. Remaining and accumulative returns as a string. And tokenize, which takes string, code, string, and returns us token list. So what are we doing first is that what we have in here. So as string code, string to chars, and tokenize loop. But why? Tokenize loop, which the remaining are char list. What's the problem over here? The expression has typed a token list, but expression and the tokenized loop are token list. So what's the problem? This one. No. Code is string to chars, and it takes a string. Stop char. Char list. Yeah, there we go. Oh. The expression has type token list, but the expression was expected of type token list. What kind of problem do we have? Should be work. Oh, we don't. Yeah. The accumulation. So we need an accumulation list first, which we don't have. So let accumulation equals an empty string in here, and we are taking the accumulative loop into there. So this expression has type list, but expression what is expected of type. Oh, string into chars. Should return us a char list, and it takes us token list, char list, token list, and token list. So we are also taking a list in here. Accumulation is token list. Alright, guess gotta do first something like that. The accumulation. Just go into there. Alright. Or, yeah, I see. To code, string into chars, and tokenize. Should be work. Should be work. It's gotta be fucking work. Yeah, what is problem over here? Let's ask the ChatGPT first. I like piping, so I will do piping. I want to do piping. And what the tokenized loop? It's just. Alright, fix. Flip the elements of definition, or first the accumulator. we keep the original one and let the count token list, and I'm gonna do this with piping. Use a small helper. Fun chars, tokenized loop chars. Pipe first. Pipe into first argument. Fun chars. Code into the string to chars. And the function chars is tokenized loop of functions. Yeah, or flip the argument option. Yeah. Code, string to chars, tokenized loop with accumulation. Yeah, should work. Or something like this. And tokenized loop apply with first the accumulation with and tokenized loop apply this stupid stuff. Code string to chars. Apply them with the accumulation. So it's a char. Oh, sorry. So char list and circle list. Wait, it should be work fine. This expression has. See, we're first applying this. Oh, we're just piping. Apply with this one. Yeah, this is not going to work right. Code string to chars. The second one is actually still. So what are these guys? This expression has type token list. Yeah. To your main guard, just char list, and accumulation is just token list. So let's delete this, and it's fucking working right now. We optimize our code with something like this. Or how about this? Tokenize loop and apply them with this. Well, it's elegant. Oh my god, that is awesome. That's why I like this language. Oops, we forgot this. Okay, so we have a tokenized loop and remaining section. So how are we supposed to tokenize char? It turns char into the tokens. So, token of char. we're just going to turn this into the token of char. We are just taking C and we are just passing it into the token of char. What it returns us is a token list. So we are just accumulate this, the accumulation. We just tokenize a char and tokenize literal, which it's a tokenized list. But why? You don't really need tokenized literal and tokenized char. So let's go back in here. What do we have? Handle numbers, handle white spaces. Yeah. Handling literals. Literal handling and lookup handling. Single char operator separator. The single char. So tokenize single char. It's just the token of char. So we have the tokenized literal, which is in here. We're gonna look back into that. We have a loop for that. So let's see what we are going to do with that. So it takes the remaining is a token list and char list. The remaining one is char list and the accumulation is just token list. So what are we gonna do is accumulation plus plus. We're gonna multiply list concat list concat list accumulation of list. What it takes listed concat is list and returns a list. So we need two lists. What are we fucking supposed to do? Alright. Well, I'm gonna think about it a little bit. Tokenize loop with code string to chars. So we have a tokenized. I don't know what are we gonna do about that. So it's a recursive function. So let's see, my brain has just died. So we're just gonna skip the white space. Let's skip the white space first. Rest account match remaining with. This remaining is done. To revive, what is revive? So match remaining with. If it's an empty. It's empty, list of revive, reversal, gotta reverse the risk, accumulation. This pattern matching is not exhaustive. Skip white spaces, C and rest when C equals or T or C. The white space match with char list. I'm just gonna copy all of this stuff. Now let's see what do we have. So it's a tokenized helper. So it's a tokenized loop. It's a recursive one. And count list. When is digits? We don't have take number, accumulate digits, literal handling, consume multiple characters in the form of a number. Tokenize helper, tokenize loop. Right. Tokenize a literal handling and lookup handling. Char of token. No, token of char. Which it takes a char and a token. It takes a char. So what do we have in here? The remaining is a char list. So else that list.map fun c and fc, and let's map. How are we supposed to do this stuff? It's a loop that skip white space. Set an anonymous function. Takes a string. Just paste this stuff. My brain is just dead at the moment. There's some syntax issues. I know. Done. We accumulated handle white space. C rest. Right? And the remaining. We are taking the remaining part that match the tokenized literal. What is that as the remaining? The char. C rest is van as digits C. Let chars remaining. No. Alright. I'm gonna deep dive into this stuff. Try to tokenize as operator and separator. Match remaining with C rest. I gotta deep dive and pattern matching first, and after that I'll continue for doing this stuff, which I don't know how I'm supposed to do it, and I don't want to copy and paste from GitHub. So we're just gonna do this. So what did we add? We added expressions, utils, the math utils, and nothing so much. So let's add it. Feet. Nicer. Add member to tokens and refactor tokenizer functions. Utils is number char. Yeah. This number. We're just gonna skip. Alright. Let's see the old way of doing this stuff. Let's think about it. At least for a moment. So we have a tokenized loop that at first does that match remaining width. So we have empty equals just listed reverse remaining or accumulation. We're just gonna reverse it. take a small list for that placeholder for now. So what are we gonna do the next? If it's remaining, what are we gonna do with that? So we're just gonna set a tokenized loop first again. Tokenized loop because it's a recursive remaining to the tokenized loop, but it's an infinite loop. Yeah, can't do this because we don't know our accumulation is. What is our accumulation? Well, let's see. Accumulation is a token list with nothing left in here. So alright. So let's recursive handle white space, which takes a char list for remaining and accumulation. So it only takes the remaining as a char list and token as a list. As accumulation equals as a char list dot instead map is a function char is char equals or not. How was that? And the white space C rest. What does that means? When C tokenized loop accumulative rest. Rest. What is rest? What is that doing? What's that doing? Let's skip first the white spaces. Match the list whose element C is a white space character. So rest. So what it's a pair matching syntax. Take the first element of the list and call it C, and call the rest list as rest. Right, I see it. So what do we have in here? Is that instead of this one, char list, it's just recursive list. All right. Remaining. Alright, it's gonna be take the accumulation. What is remaining? So in rest when C equals. Tokenized loop and accumulation and rest. We're skipping it. So when it's a white space, we're just calling it again. Don't do anything with them. There's no mutation. We're just calling the function again. cycle. Repeat cycle. I see right now. That's a placeholder. What are the rest? How about rest? So we're gonna match them with, where is the all token list? Char of token, all token info. Here's the all token info. All token info. We actually have match in here the type of token, char of token, token not found, none. Takes a token into char, but we need token of char. So what do we have in here? We still have token of char. Look at functions. So we have the unknown character. So we could use this function, and if it fails, we're gonna look into the literal handling. So we have the accumulation, but we don't need that. If it rests, the remaining is that go to the token of char, and we have the remaining, which actually char. And we also do the C rest. C token of char. Alright, we need a char list. So the accumulation is, we're gonna call it again. So we're just calling it again. The tokenized loop with the accumulation, and the remaining R is a char list, token of char. So the first one is just rest, accumulation and rest, but the token of char. We're gonna see it if it fails or not. So to match, so we're gonna match this, match. If it's an error, if it's something accumulated and move from remaining and repeat this cycle. If it fails, we're gonna try to tokenize it as literal. So the tokenized lib, if it's not known, C and rest match all token info. Sum. We already have that stuff. So we already have. We already have this function. Yeah, known single char token match try some token with there's none with same token, the tokenized loop, the token and accumulation. Alright, what the fuck is that? Token with accumulation and none is a known, not a known token, and treat as literal later. Alright, so let's go back into here. So what do we have in here is that match some token of char with none. If we have some token, the tokenized loop, accumulation and rest. I see. Match some. Match try some. Try some token of char. Let's see. Token of char. With none. With some token. Maybe a little simpler syntax and readable syntax. Alright, try to convert the char into a token. Token optional is a token of char. If none equals none. And match token optional. What is token OTP is that? match, try some token of char with none with some token or none fail with any character. Try. None. Tokenize literal. Tokenize literal. Right, how many events have been passed? Tokenize string remaining to tokenize loop. Call tokenize literal to parse it and continue. Let's tokenize literal. Oh right, I see it. Literal and remaining. And tokenize loop to region append the tokens from literal and the rest tokens from literal. And accumulation. Rest after HO or exit. Understand it right now. Let's tokens. Alright. Tokens from ritual. Tokenize literal. But we don't have two variables. But tokenize literal does not return two values. It's just one. It's just one. Return two values. Alright. Maybe you should return now. Yeah. Not literal tokens. Alright, let tokens, what it returns, tokens, literal, So token list. So we're just gonna append the list that append. There's two guys. So one guy is weak. Alright, so first one is accumulation and tokens from literal. Token is loop. Rest after literal. Rest. Oh. Remaining. So what it first takes is a list, token list, but we can't do something like this, so we're just gonna do this one. It should be fucking work. Chronicle has char list, but except the list type char is not compatible. So what are these guys are returning? Well, it's a char list, so we're just gonna apply them. Alright, we can't do that. That should work something like that, but let's see it. We're close. Well, I gotta close it. Yeah, I'm just fucking up. Idiomatic version. Current release. I wanna do this. I wanna do this with types. Application operators. What's not working? I'm gonna pipe it. Remaining into the tokenized literal and function. Tokens from literal and remaining from literal to accumulated and listed. Tokenized loop remaining from literal. Yeah, that could work. Finally. Nope. Yeah, there we go. Char list, but type token has not compatible with type char. New accumulation token has parentheses. Oh my god, why I'm making this to myself? What's the problem? Syntax error. Why? Syntax error first thing. Yeah, I definitely gotta close the screen. It's just died. Alright. Dependency cycle between. Well, we have a dependency cycle. So where is the main token, utils, separator. Alright. dot space. So here is a token list that is never used. Let's delete it. And it's working. Finally. So do failure, the exception failure, the unknown character of 1. So it's fucking working. Exception failure. Unknown character, the token of char. Let's go in here. And we only have 1 error. So it shouldn't be simple like that. Let's go into here and basket. It shouldn't be simple like that. Because, oh, yeah, we don't need that. We're not gonna do this. I don't want to fail. Instead of failing program, so I'm none. Alright, it's just none. Alright, it's just none. But we can do that. It's a token of option. And now, is it going to work? No, it's not. Cause it's actually just some T, and the way we fucking do this is okay. The token of char is an option. Yeah, it's just a non. Let's see. T and none. The option of token. It's an option. Let's go here. Tokenize loop. Some token. Yeah. Token option. Now we gotta unwrap this. Alright, it actually does that, I think. So some unwrap with pattern matching recommended. So if we have some token, the tokenized loop, where did the rest? Match token of char. Oh, match token of char. C with that's quite simple right now. Alright, just do this. Token of char. Tokenize strings. So yeah, we also gotta do some filter map token of char. Yeah, there you go. That's that, and we have the same results. It's not failing now. That stuff took me 1 hour doing. I gotta go.